Welcome to the conclusion of Chapter 8, Section 2, Part 2 video, or the conclusion of Section 2. So we left off with problem number 8 to those previous ones. If you didn't watch Part 1 video, I would like to remind you of a situation we have to worry about. Otherwise, these problems are pretty easy. Every time you start off with an even root, so we are doing that in number 8, if you end up with an exponent that's odd in your answer, you would need to put absolute values around that. If you want the reason for that, please watch video number 1. And if you are in the regular Algebra 2 class as opposed to the honors class, you will not be held responsible for this absolute value symbol. But if you are in the honors class, you will. So it's a simple memory thing, guys. So number 8, I do have to consider maybe I'm going to have to write an absolute value. So we'll see what happens. So for number 8, simple as this: divide the exponents, or divide the root number into the exponent. So 4 goes into 8 2 times. So notice I got an even exponent, which means I would not need absolute values. How many times does 4 go into 16? It goes in there 4 times. I would not need an absolute value because it's an even exponent. How many times does 4 go into 4? It goes in there 1 time. And no, you would not have to write the 1. I am just illustrating a point, and the point is that I got an odd exponent after doing an even root. So I must include an absolute value symbol in that answer. Memory thing. Please commit it to memory. Now, notice 9, 10, and 11 have no variables. If there are no variables, I would not need to consider absolute values. I need to just do the problem. So most people would look at 9 and 10 and say, well, that's scary because it's a fraction. But if you remember, fractions are just like doing 2 separate problems. It's actually pretty darn easy. Here's why. What's the square root of 9? 3. What's the square root of 10? 100. 10. And that's it. So it's just literally like treating it like 2 separate problems. So some mathematicians might make you take the time to do this. Do the top separate. Do the bottom separate. But either way you look at it, you get 3 over 10. So if you watched video part 1, I was harping on you about memorizing cube roots, memorizing the cube roots that come out even. And if you had done that, this problem would be insanely easy, because the cube root of 1 is 1. I like to think you would know that with or without a calculator, or with or without memorizing. But maybe you didn't have it memorized. Maybe you did. The cube root of 27 is 3, and that makes that problem a no-brainer. All right, number 11. Don't let all the negative signs scare you. So just like anything else, mathematically speaking, I want to start within the symbol. I want to do the stuff that's inside first. So I'm not going to worry about that negative sign that's out in front, although you know what? I am going to put a 1 there, just to remind you that it's negative 1 times something. 4th root of, so do this. What's negative 9 squared? Negative 9 times itself is 81. Now, did I ask you to memorize 4th roots? No, I did not. But you have calculators. Potentially you could do a factor tree right here. But I will tell you, if you ring up the 4th root of 81 on a calculator, or ask yourself this question: what number times itself, times itself, times itself 4 times would be 81? And that's 3. So what did that little negative sign out in front do? Well, I think it's pretty obvious. It just takes whatever we came up with, 3, changes its sign, and makes it negative. And that's it for section 8.2. So if this didn't make total sense to you here at the end here, and you did not watch video part 1, my advice to you would be watch video part 1. Either way, thanks for watching.